What if we were wrong about everything we thought we knew about these prehistoric creatures? When one paleontologist started digging at a dig site in the North Dakota mountains, he quickly found a lost piece of dinosaur history that could change everything we thought we knew about the horrible lizards that used to rule the world. The 37-year-old aspiring paleontologist managed to turn his lifelong passion into a curator position at the Palm Beach Museum of Natural History. However, Panama was perhaps best known for the widely publicized discovery he made in 2012 near Bowman, North Dakota. His love of the dead and buried was anything but peculiar. Paume and his team started digging at a location near the well-known Hell Creek Formation after receiving a tip from a private fossil collector. Paume had learned from the collector prior to the excavation that the site known as Tanis lacked much promise at first. In any case, in the wake of getting back to Tanis in 2013, the scientist found there was something else to the sun-expecting patch of rock than met the eye. Only a couple of meters beneath the surface, Paume found a large group of uncommon and strange fossils, including those of species he professed to have never seen. This puzzled Paume and his group, for it was basically impossible that this animal might have existed in the new waters of ancient North Dakota. The format of the find was additionally uncommon. The fossils stored heedlessly, and a few skeletons even covered upward in the soil. Could the asteroid that wiped out the dinosaurs have scattered the Tektite fragments found in the Tanis deposit here? The KT layer is largely responsible for the widespread belief that the Cretaceous Paleogene extinction was brought on by an impact from an asteroid. Iridium, an element primarily found in asteroids, is abundant in this 66-million-year-old band of Earth that covers nearly the entire globe. As a result, the majority of researchers assumed that the asteroid that left this crater scattered the iridium fragments that eventually killed the dinosaurs. In point of fact, the majority of fossils can be found approximately 10 feet below the KT layer. Geologically speaking, there would have been thousands of years between these creatures' deaths and the ominous asteroid impact. Even though they proposed that factors like large-scale volcanic activity and climate change had already wiped out the majority of the dinosaurs by this point, supporters of this alternative theory continue to hold the belief that the final impact of an asteroid killed all of these prehistoric creatures. Not only were the fossils he found in the KT layer, but the haphazard way they were arranged suggests that they were deposited there shortly after the asteroid hit. Dipalma hypothesized, based on this information, that the mosasaur tooth was found here because the impact's mile-high tsunamis must have traveled up river valleys and into freshwater bodies. Eager to show the world his discovery, Dipalma discussed the exclusive details of his historic find with the New Yorker. A significant number of the Pelmet's partners were vexed that the scientist had decided to impart his story to the New Yorker rather than a legitimate logical diary. After that, Paume wrote about his discovery in the Proceedings of the National Academy of Sciences, but many people thought that this account was much less detailed than his piece in the New Yorker. Paume, on the other hand, was regarded as a contentious figure in the field of paleontology even before this. He introduced Tektite, a new dinosaur species he had found in the Hell Creek Formation in 2015. The paleontologist and his team have claimed that the Tanis deposit has a lot of dinosaur fossils near the surface, but in his PNAS article, he only gives one example in a supplementary document. A study by Utrecht University researchers was published in the American Geophysical Union Journal in 2020. It sheds light on how the Earth used to be millennia ago. In addition, they did so by carefully examining a bizarre animal that had been extinct for a very long time. Yes, the ancient clan's relative had bizarre biological characteristics, and its shell served as the study's focal point. The mollusks that the group concentrated on traces all the way back to around a long time back, presently before the dinosaurs were cleared out. These organisms stand out because they built up their shells in daily growth layers, which the research team found to be particularly useful. They were connected by a hinge resembling that of an asymmetrical clam and consisted of a pair of valves or shells. The mall that is capitalized in this study was found on a shallow seabed and spent more than 9 years there. In March 2020, Brussels kneels to winter and tells Dagu that Rudis are very special because there is nothing like it in existence today. In the late Cretaceous, particularly globally, 70 million years after the fact, that equivalent mollusk has turned into an old recording gadget chronicling Earth mysteries inside its layers. The Winter and his team were able to extract mind-boggling insights from this unassuming shell through meticulous experiments. Long-standing hypotheses about the origins of Earth and the universe have been strengthened by their findings. Indeed, the review has even assisted specialists with seeing more about our moon and the job it has played in the development of our planet. Scientists already know a lot about life when dinosaurs still roamed the planet, and the shell has undoubtedly opened doors to new discoveries. For instance, geologically speaking, the Earth was in the restriction stage of the Mesozoic era, which lasted from 72.1 to 66 million years ago, as the end of the late Cretaceous period approached. At the beginning of the Cretaceous period, which lasted 79 million years, the planet underwent significant changes. The planet's landmasses were divided into 2 supercontinents, Lord Asia in the north and Gondwana in the south, a huge island. A shift that had begun in the earlier Jurassic period continued as North America moved away from Europe. India was as yet planted close to Madagascar, yet it was presently hapless and starting to move toward the north. Australia, on then again, was as yet associated with Antarctica, creating some distance from Africa and past the South Pole. During the Cretaceous, the climate experienced significant cooling, but it remained significantly warmer than it is today. Dinosaurs were able to roam Antarctica because forests covered the poles instead of ice sheets. However, these and other non-equatorial forests became more temperate as the planet cooled. The previously mentioned climatic changes at last gave way to the development of grass, deciduous timberlands, and blooming plants. However, it was still a few million years away from the enormous grasslands that would eventually cover large portions of the planet. Numerous well-known dinosaurs emerged during the late Cretaceous period as new species developed and the power balance changed. In the north, the Tyrannosaurus rex rose to the top of the food chain, and in the south, SARs did the same. Herds of herbivores like the Triceratops also inhabited the northern continents. In fact, the Cretaceous period is where many of today's birds got their start. So it's thought that pelicans, sandpipers, cormorants, and other birds all came from the Cretaceous period. In fact, the extremely ancient fossil has provided scientists with enough information to estimate the length of a single day on Earth 70 million years ago. It has also revealed an astonishing secret about the planet's rotation. Scientists did have a general understanding of how the Earth's rotation has changed over time prior to these recent revelations. According to Scientific American, the length of the planet's day-night cycle increases by approximately 1.7 milliseconds every century, but the change has been so slow in the grand scheme of things that it has been almost impossible to track year after year. The cosmic interaction of the Sun and Moon with Earth drives the phenomenon, which is effectively caused by gravity and tides. The Moon is slowly spiraling away from the Earth at a pace of roughly 1.5 inches consistently. NASA's James Williams portrayed the impacts of this pattern to the distribution in 2010. The senior examination researcher made sense of your focusing on the Moon's circle and removing it from the Earth twist. The Moon's gravity controls the tides in our seas, which dominated the previous planet's circle because of the speed at which the Earth pivots. The planet is pushed forward by the displaced mass, and at the same time, friction on the seabed slows the Earth's rotation. The cumulative effect of these factors is an imperceptible lengthening of our days. The length of our years remains the same. In any case, on the grounds that our planet's circle around the Sun stays steady. To determine the rate at which Earth is being pulled away from the Moon, Williams then determines the current rate of 1.5 inches per year by comparing changes between various results. The pattern laid out by concentrating on the moon is that the further back you go the shore are the days where. However, the interesting part is sorting out their exact length. However, studies of the Earth's tides can also provide additional information regarding the moon's formation, and the records have tended to support a general pattern dating back to earlier times that the number of days in a year increases. To be sure, the information upholds the prevailing hypothesis that the lunar body slammed into our planet a few 4.5 quite a while back. According to Lambeck, the tides would not have remained constant if it had formed outside of Earth's gravity and drifted into it. Jane Mellish, an Earth and atmospheric scientist at Purdue University, added that our planet rotated rapidly within 6 hours of the moon's impact. The moon has moved from its initial orbit of 16,000 miles to its current distance of 239,000 miles over billions of years. Yet, to truly follow the specific length of the day between those two ages, you want to dive profound into logical proof, and the previously mentioned fossil mollusk concentrated on by the colder time of year assists us with finding how the period of time in a day has changed. The scientist told Cosmos magazine in March 2020 that the rudest clammed shell is somewhat comparable to tree rings, and that the researchers could use it to accurately measure how long a day was 70 million years ago, due to the way it gradually builds its layers. The scientists carefully examined these lasers and found that the Earth rotated 372 times a year back then. This is 7 more days than it is today, making a day 23.5 hours long on average. When dinosaurs roamed the planet, the average day was actually half an hour shorter than it is today. Furthermore, this is the kind of thing that you never get in land history. The colder time of year told Dagu we can fundamentally take a gander at a day quite a while back. It's really astonishing. However, the researchers had to use a laser with extreme caution on the ancient fossil in order to accomplish this. From there, they were able to precisely estimate the length of a day when the shell was at its best. This permits us to quantify how the synthesis of the shell changed throughout brief time frame periods, and find out about exceptionally fast changes in the shell's climate the colder time of year, told Universe magazine. This model, on the other hand, made it possible for researchers to hone in on the alterations that took place throughout the course of an organism's previous life. Indeed, the clammed shell has been able to accurately reveal climate conditions 70 million years ago, in addition to the length of a day. For instance, analysis of the clam has revealed that ocean temperatures in the late Cretaceous period were actually higher than previously estimated. Those temperatures probably reached the maximum that mollusks could withstand according to the winter. He stated that the authors were able to draw 2 particularly intriguing inferences from this dataset because of its high fidelity, which helped to improve our comprehension of both the chronology of the Cretaceous and paleobiology. The study has basically provided the most precise estimation of the length of the day in the late Cretaceous period that has ever been made. The moon would have been inside the Earth just 1.4 billion years ago if the recession rate had never changed. Therefore, this suggests that the moon's retreat rate has fluctuated over time. Surprisingly, scientists have gained a better understanding of those changes by tracing a 9-year period in the life of this ancient clam. Conversing with Universe magazine, the colder time of year said the development of the Earth-Moon distance probably been more mind-boggling. Yet we don't know precisely how this sort of estimation assists cosmologists with making better models about how the Earth-Moon framework acted from the snapshot of the last planet's arrangement. 70 million years is simply a negligible part of the moon's set of experiences. In any case, so nothing unexpected going ahead. The review's creators desire to apply their new laser-centered technique to significantly more established fossils, and in doing so they desire to catch likewise exact previews of the varying lengths of days further back in time. However, the logical capability of these fossils doesn't end with concentrating on the moon. By the by, the capacity to decipher weather conditions in such detail has large ramifications for concentrating on old environments as per to winter, and thusly, it can assist with illuminating researchers about what's to come. They might show us how designs in outrageous climate and environment will advance sooner rather than later.